Hello guys, welcome back to my channel Learn with PR. In today's video, we are going to understand linked list and all four types of linked list in a very easy and clear way. So before we start, if you are preparing programming from basics, this channel is specially for you. I explain every topic in a very simple and beginner friendly way. So make sure to subscribe to the channel, press the bell icon and share this video with your friends because learning becomes easy when we learn together. All right, so let's start. So before starting this linked list, I must say you should also watch array videos so that you will have a clear concept why we are not saying array here, why we are using linked list. Okay. So now, unlike an array, a linked list does not store element in a contiguous memory actually. Okay. In array, we use contiguous memory allocation, right? But here we does not store element in contiguous memory. So each node can be stored anywhere in the memory. Okay, and they are connected through addresses actually. So you can take the example of train, suppose. So each coach is connected to the another one. Okay, so suppose coach, you say node, right? And the connection between coaches, that link you can say. Link means that address. Okay, so a linked list basically a linear data structure where elements are connected using addresses, right? Instead of being stored in a contiguous memory like an array. All right, so we have a structure for a node as well. So each node basically contain two kind of thing. One is the data. Data means that the value you are storing. Okay, and next. Okay, that means what? Means we are storing the address of the next node. That is, you can say next. Okay, so you can simply say one is data and another is the address of the next node. Okay, right? Now let's take example of it. So this is my example. Okay, I am writing node. This is one node. This is one node. The one node contains the data, right? And next is the address of the next node. These are the nodes. These are the addresses, sorry, okay, of the node. So this 5000 is the address of the first node. That is, that node contains data and address. Data is 10, okay, and node is 2000. Sorry, next is 2000. What is 2000? The next node address. Okay, so the next node address, that is 2000. 2000, this is a 2000 address for this node. Okay, this 2000 I'm storing in the first node address. Okay, right? You can say this thing. Now this is the next node 40 and 3000. Why we are writing 3000? Because 3000 is the address of the next node actually. Okay, so 3000 will store in this and 40 is the data here. Now next node we have here 30. Why it is null? I'm writing null means what? Null means what? Now you're not writing anything here. That means what? There is no next node actually. Okay, so when we have here null, okay, that means this 30 is the last element. Okay, this 30 is a last node, you can say. All right, so we are storing 2000 in the first node, right? 3000 we are storing in the next node, and here is a null we are saying. Okay, null means there is no another node connected with this 30. All right, so we have three nodes in our linked list. So this is the example of linked list. But there is one more point you need to store. That is what? 5000. What is 5000? This is the address of the first node actually. Okay, the address you need to store it. Where you will store it. Where we have to store address? We have to store address in a pointer. Okay, so now you will say I am storing 5000, right, in a pointer. So I have created one pointer storing the address of first node, that is 5000. So this is the head pointer, you can say. Okay, so this is what? Head pointer. So this is a simple example of a linked list, right? So here you will see each element. That element means one node, I'm saying. Okay, so each element node contain two things. One is a data and another is a pointer to the next node. What is pointer? Pointers to address, no? So that's why I'm writing 2000 here. Okay, so that's why we are writing contain data and a pointer to the next node. Pointer to the next node means who is pointing to the next node. That's this pointer. This is a pointer storing 2000. 2000 is the address of the next node. That's why. Okay, I'm writing here. Now linked list, you can say a non-contiguous memory allocation hai, right? This we have already discussed, right? Now we don't need to take care of that. We have to make in a contiguous location. Why? Why to? Because here we are not using it. Why? Because we have already stored the address of the next nodes, and why we required contiguous memory allocation, right? So now let's talk about linked list versus array. So if we say array, so in array we'll say fixed size we have, contiguous memory we have, and so fast access. Why we are saying fast access? Because we are doing with the help of index, right? Insertion is very difficult, okay? But in a linked list, we are saying dynamic size hai, so there is no fixed size, so you can change it accordingly. Okay, dynamic size we have random memory allocation, that means non-contiguous memory allocation, right? Sequential access hota hai, you have to make in a means you have to access, if you want to access it, sequential hoga, right? And insertion is very easy actually. Okay, so this is the word, this is linked list versus array, the basic difference. All right, now let's talk about the types of a linked list. So types, we have 4 types: singly, doubly, circular singly, circular doubly linked list we have. So let's talk about first one, singly linked list. So what is single linked list? Basically, it has what node, each element is a node. Okay, the node contains data and address of the next node. Okay, it moves in one direction only, that means forward it will go. Okay, it moves in only one direction, that means forward. All right, now singly and the previous one, that means a single simple linked list, the same actually. Okay, so I have written the same example here, you can check it. So in a singly linked list, what that is also a linear data structure in which each node contains two things, that is data and the next node address. Okay, next node address, 2000 is the next node address. Okay, so that is what, that is a singly linked list. It's a simple linked list. Okay, so the singly linked list we have. So this is very easy. I have already discussed that example. Okay. So now next we have doubly linked list. What is doubly linked list? Basically, they are having 3 parts. Earlier in a singly linked list, we were only having 2 things, but 2 things now, 1 and 2. Okay, data and the next node address. But here we have 3 part. First, the previous pointer, the previous node data you have to store. And next their data, that means 10, 20, 30, 40, whatever. Next pointer is the next node address you are storing. Okay, so this you can say can move in both direction, forward and backward. So in a singly, we were only going in a moves in a one direction, that you can say forward. But in a doubly, we have both directions, forward and backward. We have 3 part, that a previous pointer means previous node we have to previous node address we have to store, data we have, okay, and the next pointer address we have to store, next node address we have to store. Okay, we will go in the both direction in doubly linked list. Now let's take example of it. So this is, we are saying here 10, here 2000. So 2000 says what? 2000 is the next node address. That's why we are storing. But here I'm writing null. Why we are writing null? Because before this 10, we don't have any node now. That's why we are writing null. Okay. Now this is 40. 40 data, right? 5000 is the address of the previous node. 5000 is the address of the previous node. We have to store here also. And this 3000 is the address of the next node. This is the next node. All right. Now 30 again, we have 30. That's the data. Here we are writing the address of the previous node, that's 2000 we are storing here. Okay, and here after this we don't have any node, that's why we are writing null. And we will have a head pointer as well who will store the first node address. Okay, right? So this is the example of doubly linked list. So in a doubly linked list, basically each node contains 3 things. One is a data, that is 10, and the next this pointer, it's pointing to the next node. One pointer which is storing to the previous node. This you can say this 40 node, you can simply check, you will get the thing. What this is the previous node. What is previous node? That's 5000 having address. We are storing here, right? 3000 is the next address. We are storing in the next node. All right. So this is what doubly linked list. Now next we have circular singly linked list. What is it? Basically it contains only 2 things, data and next node, next pointer you can say. Okay, next pointer means who will point to the next node, who will store the address of the next node. Okay, the last node does not point to the null. This is the main difference actually. So in everywhere, in doubly also, you will see the last element contain what? Null. Okay. In singly, you will say the last node contain what? Null. But in circular linked list, the last node does not point to the null. Now, what it will take then? It will say the last node points back to the first node actually. First node address you will say. So first node. So it become what? Circle actually. It become what? Circle. Now let's check the example of it. So the example is what? That this is the example, right? Circular singly linked list. So here we are saying this is a circular now, means we are going in a loop. This is also connected. The last node actually connected to the first node. So when it's connected, that means it will store the first node address. That's why 5000 I have written here. All right. And 5000 also stored in the head node actually. Right? Sorry, head pointer actually. Right. So this is the change only in this. This is a change. That is a circular singly linked list. So in a circular singly linked list, basically the last node points back to the first node, instead writing null. Okay. Are you getting your point? Yes. So this is how we can say 5000 I'm storing here. Why? Because it's now connected to the first node. So it will take the address of the first node only. Okay. Right. So if you are understanding the concept clearly till now, then please like the video. It motivates me to create more such simple explanations for you. Okay. Now this is example of a circular singly linked list. Now we have fourth is a circular doubly linked list. So in this we have three things again. We have three things as previous pointer, data, and next pointer as well. Now here means this is the difference actually in doubly linked list and doubly circular linked list. Sorry. All right. So this is a doubly means here we are just saying these two things, but in a circular actually, in a circular doubly, basically the last node connected to the first. So that is the difference in this basically. The first node connect back to the last. So we'll say again we are forming a circular but in a both direction, right? But in this we were not connecting this 10 to the last node here. Last node is connected to the first node actually. Okay, but in this it will say it's only going in a one direction. It's only going in a one direction, right? But here it goes in the both direction. So yes, you will see like this. So this is what doubly circular linked list. Okay, so this is the first node containing data. Okay, the next is the address of the next node. This is the address of the next node 2000, but it is also storing the, it's also basically it also connected here. You will see the connection in the last node. Okay, okay, so it's also connected with the last node. This is the last node, and the last node's address is what, 3000. So that's why we are storing here 3000. Okay, right? Now the first node connected to the last actually, that's why it's taking the address of the last node first node, that is the 5000. Okay, right? This 40 contain the address of previous node, that is a 5000. This 40 next node is also it's also connected with the next node, right? That's why it's taking the address of the next node, that's 3000. Okay, the head pointer will be there, right? So this is the doubly circular linked list. So in this each node has two pointers, right? And the last node connected back to the first pointer, right? And forming a circular structure, right? So the last node actually connected here actually. So this should be here actually, right? Wait. So here you can change. So here I'm saying, right? So simple is that. Okay, so this is what we can say. We can simply change it. This is a little bit change here, right? Wait. Okay, so this is the right now. What we are saying, right, diagram, sorry, right? This is the last element actually, last node connected back to the first node. Okay, and the first node connected back to the last node. That's a circular actually, but with both direction. Why? Because we are writing here both directions we are going. Okay, so you will say the last node connected back to the first node and vice versa. Okay, so that's why it's forming a circular structure. Now let's take a detail actually, difference comparison you can say, right, among four types. So here are the four types, right? But how many pointers we are using in a singly? So we have one. In doubly we have two. Circular singly mein we are using one. Circular doubly mein we are using two. Okay, direction, this only go in the forward direction. This will go in both directions, forward and backward. Circular singly will go in the forward direction only, right? And then circular doubly will go in both direction, you will say, forward and backward as well. All right, null pointer present, where null pointer present? So singly may you will say and doubly may you will say what we have. Yes, we have null pointer present, but in circular and doubly circular we don't have any null pointer as they are connected actually to the first element and vice versa. Last node connects to first. Last node connected to first where in circular singly and circular doubly only. All right, but in these two we don't connect actually, right? Now where we say memory uses less and more. So you will obviously when we are using only one, when we are using only one pointer, right? That means one now. Okay, so that means what? Less here memory, but here will be more. Two pointer we are using, here we are less, we are using only one. Here we are two pointer, this is more. Okay, so memory usage is what? More, where we have number of pointer more. Okay, traversal starts from where? It will start from head. It will start from head or tail, anywhere. But circular and circular doubly में we can start from anywhere, any node, कहीं से भी आप you can start traversing. Okay, now next implementation. So you will see singly is the only one which is having a easily implementation. Means in any kind of code you can make very simple singly. Okay, now but double and you will say circular and circular doubly, it's a very complex. Here we'll say moderate, but this is very complex as we have to connect it both nodes actually, right? So this is a clear explanation of your linked list and 4 types of linked list. Okay. So if this video help you to understand, right? So please like the video and share it with your friends who are learning DSA. Okay. Do not forget to subscribe to the channel, press the bell icon. In the next video, we will understand how to traverse in a singly linked list with example and code. Till then, keep learning, keep practicing, and keep growing. Okay. Thank you for watching.